handy. So we took the rocket equation from class here, and went down and plugged it into Mathematica, conjugated, got that, and just see I could do it. And I put a manipulate command with using the rate as the variable. I couldn't figure out how to do it with the size of the pebble thrown. But you get this kind of cool thing going on here. We know it's going to make this shape because the mass is going to decrease to the end to be only 1 kilogram at the very end there, which is why I'll do this kind of falling thing and then come back up. And obviously we didn't say it can't fall down, which is why it's falling. So this is kind of like an arbitrary starting point in the middle of the atmosphere, but it can fall down. I noticed it didn't have a straight line anywhere for the hovering point, so back to this equation here. I tried some other to work with that equation because we go to each other and I kept getting accelerations all screwed up. So I went back to the basics. Free body diagram. Gravity going down, the mass of the pebble you throw times its acceleration went up. And this is the total mass, and this is the mass of the pebble you're throwing. So this is mass minus mass of pebble. So this 100 minus 1 is t, which we kind of used before. I just use that again. And then this is going to be just times 1 because mass of pebble is 1. But the acceleration is going to be the velocity of how fast you throw it and how much time you throw it. We're doing all this by a second. So I just use this as 1, which makes the velocity this kind of wonky thing here. So that wonky thing, if we plug it back in for the u of t, because we said this is the rate, right, which is our velocity, we get something that looks like this. So I plugged that in and got the straight line. It's right on the axis, but again, since we said that gravity doesn't exist, it makes sense. That's just kind of floating in midair then, hovering, doing its thing. So, yeah.